Bismillahirrahmanirrahim. Today I am going to explain the chemistry of the Tollen's test. This test is specifically used for the identification of aldehydes. One can use this test to identify the aldehydes. One can employ this test for the identification of aldehyde, uh, the presence of aldehyde in any mixture, or the presence of pure aldehydes. You can confirm those by using Tollen's test. That is pretty specific for it. Why we use Tollen test? Why we need to identify the presence of why we need to identify actually the presence of why we need to use Tollen's test, why we need to identify the presence of aldehydes. Let me give you a bit brief background of this test, why we apply that. What is the background behind it, why we use it. Once we told you, let's say we have given you some unknown organic compound, and we ask you to identify its chemistry. What you do actually at the right outset of the analysis, for the confirmation of the compound, you are supposed to start with the litmus solution test. This is the test which determines your line of action, the future tests that you need to perform to identify any given unknown compound. So you start with the litmus solution test. Let's say your litmus solution confirms that your given compound is some sort of a neutral entity. It's a neutral. In case of neutral, there are two chances that the given compound could be a carbonyl compound, that the given unknown compound is a carbonyl compound, the number one option, or it could be a carbohydrate. So once your litmus solution confirms the given compound is a sort of a neutral entity, you will be left with two choices: carbonyl compound or carbohydrates. So how we can identify this one? We told you on that day, you can go for 2,4-DNPH test. This test confirms the presence of carbonyl compounds, aldehydes, as well as ketones as unknown compounds. So 2,4-DNP test is the test that confirms the presence of aldehydes or ketones. What is the chemistry? What happens inside the test tube that confirms the presence of aldehydes and ketones? What are the reactions which are involved in 2,4-DNP test? I've explained those in a very last lecture. That is 2,4-DNP test, a mechanistic inside, a test, a video lecture uploaded on YouTube. So you may consult that to get an insight about the 2,4-DNPH test. So this is how the 2,4-DNPH test helps us to identify actually the presence of carbonyl compound. So once you came to know that there is a carbonyl compound is present, then definitely you need to confirm whether that is an aldehyde or a ketone, because 2,4-DNPH test is the test which provides information about the carbonyl functionality, mean both aldehyde and ketones are confirmed by this test. However, once you want to distinguish between aldehyde and ketone, whether the given compound is aldehyde or a ketone, then you need another test that is specifically only for the aldehydes. If aldehyde is present, that test will be the positive, that is Tollen's test. Tollen's test, if that turns out to be positive, mean your carbonyl compound is an aldehyde. If that test turns out to be negative, means your compound is a sort of a ketone, not an aldehyde. So that's what the chemistry behind the Tollen's test. It actually helps to differentiate between aldehyde and ketone. So aldehydes only undergo reaction with the Tollen's reagent. What happens in Tollen's test? What is the mechanism behind that test? What is the chemistry? What happens inside the flask, inside the test tube? That's what I'm going to explain. So I'm discussing about Tollen's test, that the Tollen's test helps you to differentiate between aldehyde and ketones. It's only for the aldehydes. Let me explain the chemistry in Tollen's test, getting back to its mechanistic insight. For Tollen's test, we use Tollen's reagent. We need Tollen's reagent. What is that? We use actually silver nitrate. Ammonium hydroxide, we use actually silver nitrate along with ammonium hydroxide. What happens then? Actually, we have some sort of this sort of a complex, that is, yes, it is called ammoniated silver nitrate. It's a sort of a complex actually that we use as a reagent for the conformation of presence of aldehydes. What is important about it? It's a weak, not it's not a very strong, it's a weak oxidizing agent. It's a weak oxidizing agent. It oxidizes only aldehydes, not ketones. Not ketones. It oxidizes only aldehydes, not ketones. Why? Because it's a sort of a weaker oxidizing agent which can oxidize only aldehydes and not the ketones. I've just written over there, it's a ammoniated silver nitrates, where this silver is supposed to be in +1 state, +1. Its oxidation state is +1. What happens actually during this Tollen's test, if we have an aldehydes and ketones and we react them with ammoniated silver nitrate. What happened during this test? Actually, the aldehydes are converted into, R means any alkyl group, aryl groups. They are converted into acids, carboxylic acids. What has happened? One of the oxygen has been introduced over here. Addition of oxygen, that is supposed to be oxidation. It has undergone an oxidation, during the reaction of the aldehyde with ammoniated silver nitrates. What has happened inside the test tube? The aldehydes has undergone an oxidation. They have been converted into corresponding acids, carboxylic acids, we call it carboxylic acids. That is carboxylic acids. At the same time, what happens? The silver, which usually originally carries positive 1, it becomes Ag0. So mean it has got reduced. Ag undergoes a reduction in this test, while the aldehydes undergo oxidations. So basically what happens inside the Tollen's test, we use ammoniated silver nitrate solution for a reaction with aldehydes. The aldehydes undergo oxidations. They become the corresponding acids, carboxylic acids. However, the silver, which was supposed to be +1, this plus is supposed to be due to the silvers, the silver gets reduced to Ag0. We have an idea, metals in their zero oxidation states, that the silver, that is the main existing form of the silver, This silver, which is in the form of Ag0, it gets deposited along the walls of the test tube. It gets deposited along the walls of the test tube, Once there is a reaction between aldehyde and ammoniated silver nitrate, in fact during this reaction, the aldehyde has undergone an oxidation, whereas the silver has undergone a reduction. As a result of a reduction, the silver has become Ag0, which becomes which becomes the general form of the silver. That general form of the silver gets deposited along the walls of the test tube, and it appears like a mirror. It appears like mirror. That is why it's also called silver mirror test as well. So Tollen's test is also called silver mirror test. During this test, what has happened? Aldehyde and aldehydes has undergone an oxidation to become acids, but we don't detect those acids, But we detect that the silver has been deposited against the wall of the test tube on a flask. It gets deposited when it is in the reduced form, when it's Ag0, then it gets deposited. So once it gets deposited, we do believe that there has been a reaction between these two bodies. As a result of that, it has produced a sort of a corresponding carboxylic acid, and then the silver has got reduced to Ag0. That's a common form of the metal, and that common form of the metals gets deposited against the walls of the test tube, and it appears like a mirror. One can see just like it's a sort of a mirror, you know. It appears like, it glitters like mirror. So one, we also call it silver mirror test on the basis of the presence of the silver along with the walls of the test tube. So this is what has happened in the silver mirror test. The ammoniated silver nitrate has the capacity to oxidize only aldehydes because it's a weak oxidizing agent. It's not a, because it's not a strong oxidizing agent, that's why it cannot oxidize ketones. It can oxidize on aldehyde. So once you see the deposition of the silver around the walls of the test tube, it can be presumed that you may come up with the result that the given compound is an aldehyde and not a ketone. Okay, so this is how the Tollen's test lets you to get to the bottom of the conclusion that the given compound is sort of an aldehyde, you know. This is the general representation of the test. What has happened? Aldehydes, ammoniated silver nitrate, oxidation of the aldehyde into the benzoic acids, carboxylic acids in fact, and then the reduction of the silver. This is how it happens. What happens in fact? How it gets oxidized, how it gets reduced. That's the main thing that happens actually inside the test tube. I will try to convince with a bit logical mechanism that is involved in it. Let's see together what happens inside that, you know. So what happens actually inside this in this test, you know, that is actually we have this sort of aldehydes. Due to the electronegativity difference between the carbon and the oxygen, you know, this bond is moved towards the electrophilic electronegative oxygen, giving a positive charge, a sort of a positive charge, you know, at a sort of a positive charge at oxygen. Negative charge actually will be on the oxygen, a positive charge over here. At this point of time, when oxygen is rich of electrons, Ag positive, which needs electron actually, it comes closer to the oxygen, the carbonyl oxygen. So one of the electron which has been jumped from the carbon to the oxygen, that is given away to the silver. So as soon as silver receives the electron, the positive charge will disappear. It will become a sort of Ag, I would say Ag0, you know, means it got reduced. So this will become a radical, you know. It will become a radical because oxygen has lost one of the electron. So it has become a sort of somebody having electron deficiency at the moment. So it will look like over here. So as we have an idea, at the same time this body carries positive charge as well. So one of the hydroxyls, OH negatives, which are present in the solution, because it came from the ammonium hydroxide, it can attack over here. So it becomes something like that. It will look something like that, you know.
Look at this small.
this is how it happens. Then what happens? There is a one proton from the aldehyde, that is the carbon, we have an idea about it. This moves from here to here with one of its electron which is with hydrogen. It moves from here to here to the oxygen. So it will become like this, and then we will have the hydroxyl which got already attached with this one. Actually it was a proton over here. So this is how it is supposed to look like. So this is how it is supposed to be at the moment, So one of the electron from this bond between carbon and hydrogen has moved from here to here to make a bond between here. So what has happened, the carbon will carry only a singlet, one electron over here, so it will become also a radical at the moment. So what happens then, another Ag positive, another silver ion, which is available inside the test tube, it comes over here, and then this electron is given to it, as we have an idea, because it is carrying positive charge. So one positive can be neutralized with one electron, So what happens then? We will have OH, we will have OH, something like that. So it has given away its electron from here to here. So again it will carry a positive charge. So what happens, we have an idea inside the again test tube. We have hydroxyls available from the ammonium hydroxides. Those hydroxyls are around. So what can happen? This hydroxyl can obstruct this proton, and then this bond is moved from between this bond is moved from here to generate a double bond between carbon and oxygen. So what happens then? We will have something like that. So here is our R, So this is how resultantly we have received the carboxylic acid. This is called carboxylic acid. This is called carboxylic acid. During this carboxylic acid formation, starting from aldehyde, what is happening? Those silvers are being converted into Ag zeros, and these Ag zeros actually get deposited on the walls of the test tube, and that what we observe, as soon as these are produced, we see a sort of a mirror. So we assume that this Ag positive, Ag0 has been produced through this reaction, and this reaction is only possible with aldehydes. So this sort of carboxylic acid, they are also present in the test tube. We don't monitor those, they are the organic compounds, What is easily monitorable, what is easily detectable, that is the formation of silver ions. Not ions actually, silver metal, in the form of a neutral metals. Once they are produced, you can imagine that those Ag zeros would have been generated through this reaction, and this reaction is only possible once your starting compound with an aldehyde. Once your starting compound is a sort of a ketone, this will not be possible. Let me explain it again. We have an aldehyde, we put that into the test tube, and we put in ammoniated silver nitrate. Out of that, we have an idea over here, due to electronegativity difference between carbon and oxygen moves up, means this oxygen becomes electronically rich and the carbon becomes electropositive, it becomes positive center. This silver which is floating in the test tube silver ion, it comes closer to the oxygen, gets one of the electrons to neutralize its charge and becomes Ag positive. What has happened? This oxygen has lost one of the electrons, so it will become a radical, So in order to, it has become a positively charged radical, because at the same time the carbon carries positive charge and the oxygen carries a singlet electron. So one of the hydroxyl from the solution, it can attack over here in order to neutralize the positive charge. At the same time, this singlet electron is also stabilized by the movement of the proton from the carbon to the oxygen with one of its electron to develop a new bond with oxygen. What happens then? Resultantly, this carbon carries singlet electron, mean again it becomes a radical. So what happens at this point of time? Any other silver ion, a lot of silvers are floating inside the test tube, so it can come closer and gets electron from the carbon, becomes Ag0 again, and then it gets deposited on the test tube. As a result, the carbon is supposed to carry positive charge. In order to neutralize the positive charge, this bond between oxygen and hydrogen is moved from oxygen and hydrogen, and it jumps towards oxygen and carbon. As a result, what we receive, this is called a carboxylic acid. So this was our required product. As we told you in the beginning, that aldehydes, when they undergo Tollen's test, react to Tollen's reagent, they become oxidized to corresponding carboxylic acids, and also the silver becomes reduced. The silver is a part of Tollen's reagent. It's an ammoniated silver nitrate. So this is the chemistry behind the Tollen's test. This is what happens inside the test tube actually. This reaction which happens inside the test tube, it produces silver zeros, means silver metals, and that metals gets deposited along the walls of the test tube, and those deposited silver appears like mirror. So the formation of mirror, the appearance of mirror along the wall suggests that the reaction has happened with Tollen's reagent. So we call it a silver mirror test or Tollen's test, which confirm the presence of aldehydes. It helps to distinguish between aldehydes and ketones. If you do perform the same reaction with certain ketones, you start putting in ketone and then put in your ammoniated silver nitrate solution into the test tube. Let it rest for a while, then you will not see any formation of any silvers along the walls of the test tube, because the Tollen's reagent, that is ammoniated silver nitrate, is a milder, it's a weaker oxidizing agent. It can oxidize only aldehydes. It cannot oxidize ketones. So this is how this test can help you to identify aldehydes. This test can help you to distinguish between aldehydes and ketones. Once your 2,4-DNPH test becomes positive, then you need to go for this test so that you can identify the actual carbonyl compound, whether aldehyde or a ketone. If your 2,4-DNPH test becomes negative, means your carbonyl compound, means not aldehyde, not ketone, both are absent, then what is left in that group? That is supposed to be the presence of carbohydrates. And if the carbohydrates are present, how the carbohydrates could be confirmed, that's another story. We will discuss the confirmatory test of carbohydrates in upcoming lecture inshallah, and I will upload on the YouTube as well. for your very convenience, you can uh, follow the lecture in order to identify the kinds of carbohydrate. So that's all about Tollen's test. That's all about the distinguish of aldehydes from the ketones. That's all about the follow-up test of the 2,4-DNPH test. If you have any question, please don't hesitate to ask me. You can put your question in comment area, or you may approach me through WhatsApp or email. I will be happy to respond at the earliest possible, inshallah. I hope you got the idea what is Tollen test, so it can help you. What is the chemistry, what happens, how your aldehyde oxidizes, and how the silver, which is an oxidizing agent, part of an oxidizing agent, gets reduced. So that's all from my side. If you do have any question, please come up. I will be happy to respond. Thank you very much. Assalamu alaikum.